Welcome to Study Loop.
So we have 1 kilogram of water and we boiled it off at 100 degrees Celsius. Now we want to find out the amount of work done. Obviously, the amount of work done is P delta V at constant pressure. So we simply need to find the change in volume. So we have water, which got converted into water vapor, which is a gas. So we'll consider that this water vapor is an ideal gas for the sake of this problem. So water is simply mass divided by density. So mass is 1 kilogram, and we know that the density of water is 1 kilogram per liter. So that's 10 cubed kilograms per meter cubed. So that's 10 power minus 3 meter cubed. And the volume of the water vapor, because it's an ideal gas, we use the formula nRT by V. nRT by P. To find the number of moles of water, we divide the mass of water by the molar weight of water multiplied by RT and divided by pressure. The mass of water is 1 kilogram. The molar mass of water is 0.18 grams, which is 0.018 kilograms, times R is 8.314 joule per mole Kelvin, times the temperature is 100 degrees Celsius, but do not forget to convert it into Kelvin, which is 373 Kelvin. Divide by pressure, which is 1 atmosphere, which is 1.01 into 10 power 5 pascals. Now this turns out to be 1.70 meter cubed. If you notice this is a very large volume compared to this volume. It's almost 1700 times larger, which means we can simply consider the initial volume to be 0. So work is P delta V. This is part A, by the way. So that's pressure, which is 1 atmosphere, which is 1.01 into 10 power 5 pascals, times the change in volume is 1.70 meter squared. Meter cubed. This turns out to be 1.72 into 10 power 5 joules. This is the amount of work done by the gas. Now, for part B, we want to find out the change in the internal energy. To do that, we know that the change in internal energy is Q minus W, where Q is the amount of heat added and where W is the work done by the gas. So we simply need to find the amount of heat added. And to boil the water, the amount of heat added is simply mass times the latent heat of vaporization. The mass is 1 kilogram times the latent heat of vaporization is 2260 kilojoules per kilogram. It's 2.2 into 10 power 6 joule per kilogram, if you want to write it that way. And this turns out to be 2.26 into 10 power 6 joules. Therefore, the change in internal energy is Q minus W, which is 2.26 into 10 power 6 minus 1.72 into 10 power 5, which turns out to be 2.09 into 10 power 6 joules. This is the change in internal energy of water. It's 2.09. That's it.